Hello students, today we will continue our same chapter, that is density, or you can say measurement of physical quantities, and in that we were doing about density. In our last video we did about the formula to calculate density, and that formula is density is equal to mass upon volume. Today we are going to learn how to measure the density of any of the substance, and today we are talking about first of all about solids. Suppose this stone is given to me and you ask me to find out the density of the stone. This is a stone piece. So how can I calculate the density, or how can I measure the density of this piece of stone? By using this formula I can calculate the density very easily. And from this formula I know that I need mass of the stone and I need the volume of stone to calculate the density. Mass easily I can measure with the help of physical balance. With the help of physical balance and using standard weights, I can come to know easily about the mass of stone very easily. Say that is 5 grams when I measured it. Okay, now the second thing is I should know about the volume of the stone which is given to me to find out the density. So how to find out the volume of the stone? It depends on the shape of stone, beta. If stone is of regular geometric shape, then easily we can apply the geometrical formulas to find out the volume. Suppose the shape of the stone is cubical, it is cube in shape. Okay, so simply we can apply the formula to find out the volume of cube, that is side into side into side, and I can easily calculate the volume of the cube, means volume of the stone, because this stone is cubical in shape. So from here I can find out volume of stone, say it is 5 centimeter cube. So easily I can calculate the density by substituting these two values over here, because I calculated the mass of the stone as 5 grams and the volume of the stone is 5 centimeter cube. Okay, so this way density is given by mass upon volume, that is 5 upon 5 is equal to 1. This is gram centimeter cube inverse. Fine. But what if the shape of the stone is not regular? Means it is not in cylindrical shape, it is not in cubical shape, it is not in cuboidal shape. If it is irregular in shape, means shape is not regular geometric shape. Suppose the stone given to me is of this shape, then how can I find out the volume? Mass though I can find out with the same method, that is using physical balance. I simply put this stone piece onto the physical balance and I compare it with the standard weights, and I can get to know about the mass of the stone, and maybe that is 5 gram only, 10 gram, whatever will be the mass, that I will write over here. Say in this case the mass of the stone is 10 grams. In this case I am saying mass of the stone is 10 gram. I measured it with the help of the physical balance. But in this case, how can I find out the volume of the stone? Because the shape is not regular. Which formula I should apply over here? I cannot apply any such formula over here because I don't know the formula to calculate the volume of this shape. So what can I do? For this, we can do a simple method that is known as liquid displacement method to find out this volume. Means to find out volume of irregular solids, we can use a method that is known as liquid displacement method. As the name is suggesting, liquid is displaced, but with the help of what? With the help of this irregular shaped substance which is given to us. Whenever we will put any solid into the liquid, this solid is able to displace a certain amount of liquid which is equal to its own volume. I am again saying, whenever we will put any solid into the liquid, this solid is able to displace a certain amount of liquid which is equal to its own volume. How can we do it? Let us study. We will take a measuring cylinder In this measuring cylinder, graduations are marked. Graduations, I believe all of you understand. These markings which represent the value of the liquid present in the cylinder. Okay, I'll pour water into this measuring cylinder and note down the initial reading of the water. Suppose this is the stone, I am drawing it over here. Suppose this is 50 ml. Okay, this is the initial reading of water and I am labeling it as V1. Okay, now what I have to do is I have to tie this stone with the help of a thread, and then I can suspend it or put it into the measuring cylinder. Okay, when I will put this stone into the measuring cylinder, as I told you, this stone or this solid is able to displace liquid. How much liquid it is able to displace? Equal to its own volume. Okay, as it is able to displace the liquid, तो जो liquid यहाँ से displace हुआ है, that liquid will be observed over here. The level of the previous liquid rises and it gives a new reading now. And what is that new reading that we can note down from here? Say it is 55 ml. This is just for an example. These readings are just for an example. The final reading I am denoting with V2. Okay. So what is V over here? V is V2 minus V1. V is what? V is volume of stone. This is volume of stone, and that is given by what? That is given by final reading of water minus initial reading of water. That is 5 ml. Okay, that means this is volume of stone. But as we people are aware that the volume of solids that we are measuring into centimeter cube. So we can convert this ml into centimeter cube. We are aware 1 ml is equal to 1 centimeter cube. So here what is given? 5 ml. So 5 ml is equal to 5 centimeter cube. So that means the volume of stone is 5 centimeter cube. Now I believe I have both the values with me to find out the density. What are both the values? First is the mass, which I calculated here, 10 grams with the help of the physical balance, and second is what? Volume of stone, which I calculated with the help of this liquid displacement method, that is 5 centimeter cube. And I can substitute both the values in the formula. That gives density is equal to mass upon volume, that is 2 gram centimeter cube inverse. This is how we can calculate the density of irregular solid. Okay, I am again repeating this method. This is liquid displacement method. What it says? It says, I am writing it over here beta. It says when irregular solid or any solid, not only irregular, when irregular solid or any solid is put into liquid, it displaces a certain volume of liquid which is equal to its own volume. Its own volume. On means kiska? Solid, which is equal to its own volume. This is liquid displacement method, and this same we are using over this what liquid displacement method same, and the same we are using with the help of measuring cylinder over here to find out the density of volume of irregular solids. What we did over here, we learned how to find out the density of a solid. The solids can be of two shapes. One is of regular shape, another is of irregular shapes. For regular shapes, we can simply apply the formula. We can find out mass with the help of the physical balance. We can find out volume with the help of simple geometric formulas according to the geometric shape of the solid. And we can substitute the values and we will get to know the density of the substance. But if the shape of the solid is not regular, it is not any known geometric shape, then it is irregular solid, and in that situation we need to apply this liquid displacement method. What concept we are using over here? When irregular solid or any solid is put into the liquid, it displaces a certain volume of liquid which is equal to its own volume. This is the main concept which we are using here in this liquid displacement method. According to this, we will take a measuring cylinder, we will pour water in this, and after that we will measure the initial level of the water with the help of the graduations marked on the cylinder. Okay, say that is V1. Then later on we will put the stone or any irregular solid which is given to us into the liquid, and then we will note down the final reading, which is the raised water now in the measuring cylinder because of this stone present into the liquid, and say that is V2. Then V2 minus V1 gives us the volume of the irregular solid, and this volume is in milliliters because we are measuring the things in measuring cylinder in milliliters. Okay, then we will convert this milliliter into centimeter cube because in case of solids we are representing the volume in this unit, that is centimeter cube. 1 milliliter is equal to 1 centimeter cube. Whatever you calculated this raised value V2 minus V1, say it is 5 ml, so that gives you 5 centimeter cube. This way we can come to know about the volume of the irregular solids. And mass we can find out with the same method, that is with the help of physical balance. Volume we calculated just now. By substituting both the values we can find out the density of the substance this way, and we can express it into its units. If somebody will ask us, okay, we need to write it in SI unit, then we can convert the CGS unit into SI unit by using the relation. Okay, now next thing what we need to learn is, this is we have learned in case of solids. But what if somebody will give you liquid and ask you to find out the density of that liquid? Then what can we do? Then also it's not very difficult, beta. In case of liquids, we can measure density with the help of two methods. One is by using physical balance, or you can say beam balance. By using beam balance and measuring cylinder and measuring cylinder, and second we can use density bottle, and second we can use density bottle. These two we are using to measure the density of liquid. In the previous one we have done about to measure the density of solids. Okay, now how to find out the density of liquids? Let's start with this first method, that is by using beam balance and measuring cylinder. Okay, beam balance is used to measure the mass of liquid, and measuring cylinder is used to measure the volume of liquid. Okay, volume of liquid is directly measured with the help of measuring cylinder, as we have done in our previous concept, that is for solids. This is measuring cylinder. We will pour the liquid into this, and whatever value we will notice over here, say this is 15 ml. So this is in milliliters, so we can say 15 ml. We can convert it into centimeter cube too by using the same relation. 1 ml is equal to 1 centimeter cube, and we can say this is 15 centimeter cube. This way we can find out the volume of the liquid which is available with us to find out the density. Okay, now the question is how to measure the mass of the liquid, because directly you cannot pour the liquid onto the beam balance or onto the physical balance. This way it will spread over the surface. So for that what we need to do is we need to take that liquid into a container. Okay, so if we are taking that liquid into the container, then what will happen? Then we are measuring liquid along with the container, means that is not the mass of the liquid only, that value is the mass of liquid plus container. But here what we need mass of liquid only, because we are aware the density is given by what? This is given by mass upon volume. If we are supposed to find out density of liquid, then mass of liquid upon volume of liquid, right? So how can we find out mass of liquid by using beam balance? First we will measure mass of liquid with container, because we are pouring it in a container, or you can say beaker with container, or beaker, anything you can write here, or vessel, whatever you feel comfortable with beaker. Okay, say it is m1 gram. Okay, then what you need to do is you can pour out the liquid from the beaker or the container or the vessel, and then you can measure the mass of that beaker, that container or that vessel independently. Okay, so here you are going to write down mass of beaker after pouring out the liquid from it. So what it gives? It gives you what? It gives you m2 gram. Okay, now this is empty beaker, this is beaker with liquid. So how can we find out mass of liquid? Mass of liquid is given by, say it is m, that will be given by m1 minus m2 gram. This gives the mass of liquid. How can we understand in numerical terms? Suppose this mass of liquid with beaker. When you have taken liquid into the beaker, then total mass is say 15 gram. When you poured out the liquid and you measured this beaker only, then the mass is suppose 10 gram. So what is the mass of liquid? 15 minus 10, that is 5 gram. From here you calculated mass. This way you calculated volume. Now easily you can find out the density by substituting the values. This is how we can find out the density of liquid with the help of beam balance and measuring cylinder. Okay. Now second thing is, how can we find out the density of the liquid with the help of density bottle? Now density bottle is a device which is used to measure exact volume of the liquid. Okay, mass we can measure directly. Density bottle is a device which is used to measure the density of a substance. Okay, how it can measure the density of a substance or how it is designed? This is made up of glass whose bottom is flat and it is fitted with a stopper at the top, or this stopper has a fine hole at the tip. Okay, now we will pour the liquid whose density we are supposed to calculate, and its capacity is 50 ml only. Every time its capacity is 50 ml, means it is able to hold 50 ml of liquid. Okay, so why we are putting this stopper which has a hole on it, over it, after filling it? There is a reason. The reason is when you will fill it with the liquid, it holds a certain amount of liquid. When you will place the stopper over there, as the hole is present in the stopper, the extra amount of the liquid every time comes out, and it is able to hold a certain amount of volume of a particular liquid or any of the liquid every time. That means every time it is able to hold a same amount of volume for all the liquids, and this way we are able to calculate correct value of density of liquids. This is another method by which we can calculate the density of the liquids. So in this video what we learned? We have learned about two methods. One, how to find out the density of solid, and second, how to find out the density of liquids. When we have discussed about the density of solids, beta, we have discussed about only measuring cylinder. One more thing is mentioned in few of the books. Let us discuss that too, because it is related to this topic only. Instead of measuring cylinder, while we are measuring for solids, density for solids and which are irregular in shape, we can use Eureka Can too. What is this Eureka Can? This is a beaker like structure with the opening near its top, this way. Okay, and this opening is known as spout. Okay, how we will use it instead of measuring cylinder? We'll fill it with water. The extra amount of water will come out from here, and water settles down itself to a particular level. Every time it settles down itself to this level. Okay, because if the level of the water exceeds from here, it will start coming out from the spout. Okay, then whatever solid is given to us, we'll take that solid and suspend that solid into this Eureka Can. Immerse that solid completely. Immerse that completely means we will dip that solid completely into the Eureka Can. Okay, say stone was given to us, and this stone I dipped into the Eureka Can's water. Okay, now after putting this stone, the water will start coming out. Okay, so what we need to take care is, we need to place a beaker before putting the stone into the Eureka Can. Where we need to place the beaker? We need to place the beaker under the spout, this opening of the Eureka Can, so that when we will put the stone and the extra amount of water, the level of water rises after putting it over here, because I told you whenever a solid is placed into the water, it is able to displace certain volume of liquid which is equal to its own volume. So in this case also it happens, this stone is able to displace some amount of water and the level of water rises up to here, and water will start coming out from the spout. Okay, when water will start coming out from spout, and if we placed a beaker under it, so we are able to collect that water into the beaker. Means how much water we are able to collect? The displaced water we are able to collect. Okay, so when the displaced water is collected into the beaker, after that the water will stop coming from the spout. Okay, then we will take the water which we collected into the beaker, okay, and then we will pour this water into the measuring cylinder. When we will pour this water into the measuring cylinder, we will get to know how much water is displaced by the stone, because here we can measure the amount of liquid. Suppose this is up to here and this gives you 10 ml. So again we can find out 10 ml of water is displaced by the stone which we collected here in the beaker, and now we placed it into the measuring cylinder. Okay, now if we are saying it is 10 ml, so again we can convert it into centimeter cube to find out the density of stone. And how can we convert it? 1 ml is equal to 1 centimeter cube, so it gives us 10 centimeter cube. This way also we can find out the density of irregular solids, because we came to know about now volume, mass, exactly we can calculate with the same method with the help of physical balance, and we can come to know about the density of irregular solids with the help of this method too. Now today we have done with the measurement of density for the solids, regular and irregular, and we have done about the measurement of density of liquids. You are supposed to read out the content related to these two topics from your book, and in next video we will continue about the relative density concept. Okay, till then, bye bye beta.